Ethanoic acid, or it is also called as acetic acid. This particular compound belongs to the functional group of carboxylic acid, and 5 to 8% of acetic acid in water is called as vinegar. The melting point is 290 Kelvin. Now, since it freezes during winter and this frozen acetic acid looks like ice, so that's why it is also called as glacial acetic acid. This acetic acid is used in different areas. In food industry, it is used as food preservative. In medical field, it is used to treat infections and dreadful disorders. Now, reactions of ethanoic acid. The first one, esterification reaction. When an acid and alcohol reacts in the presence of acid catalysts, then it dehydrates to form ester. Dehydrates, I've already told you all, means removal of water molecule. So if I consider ethanoic acid, so basically this statement tells you that an acid and an alcohol reacts in the presence of some catalyst to give you ester and water molecule. Dehydrate means it indirectly tells you that there is a water molecule that is being given out. So here in this case we are considering the example of ethanoic acid. So ethanoic acid CH3COOH. Mind you, you have to count the number of carbon atom that is there in the functional group also. So counting that carbon atom and one more carbon atom, I have two carbon atoms, that's why it is ethanoic acid. And here it is ethanol C2H5OH or CH3CH2OH. In the presence of concentrated H2SO4, it will give you ethyl ethanoate. Now this is an ester. Ester is a group of it is a functional group. So it is a family which, or the general form of an ester is RCOOR. So dash COO dash is the functional group that is present over here, that is ester. So over here, if we consider the example, ethanoic acid and ethanol with the presence of a catalyst that is concentrated H2SO4 will give you ethyl ethanoate. This is an ester with a molecule of water. So acid plus alcohol in the presence of a catalyst dehydrates. Dehydrate means indirectly tells you that it gives you water molecule to form ester. Now this particular carbon compound is an ester. Ester is one more functional group, and the basic formula of an ester is dash or R. CR means alkyl group, means it is basically ethane group with one hydrogen atom less. So R COO R. This will be one alkyl group CH3, and the other alkyl group is C2H5. Now the naming of this ester is not taught for you all in detail, so I'll just tell you roughly what it is. So if I consider this as one alkyl group, this is eth, 2 carbon, so ethyl, and this together CH3COO, this together it is called as ethanoate. So 2 carbon, that's why it is ethanoate. Esters are named like this. So ethanoic acid, ethanol gives you ethyl ethanoate, that is an ester with a molecule of water. So what generally happens over here is, here hydrogen is getting broken up, bond. Here OH gets separated. So here H and OH will form water molecule. This C2H5 will come over here and fill that vacant space, that is that wherein the hydrogen atom was removed. So हितूंतल्यान कितें जाता, हांगा OH bond separate जाता, हांगा H atom separate जाता, हो H आणि हांगाचो OH असा तो वॉटर मॉलिक्यूल फॉर्म जाता. आता उरिल्ले C2H5 असा तो हांगा bonding जाता. So the final product you get is CH3COO C2H5. Now this generally esters have a sweet smell and hence it is used in making perfumes and flavoring agents. Here this diagram shows how the experiment is taken place. Now the next reaction is saponification. The next topic is saponification. So the reaction in which on treating with sodium hydroxide, that is NaOH, which is an alkali, the ester is converted back to alcohol and sodium salt of carboxylic acid. Now saponification reaction tells you that in the presence of sodium hydroxide, this is a catalyst, sodium hydroxide, ester, that is RCOOR compound, gets converted back to alcohol and sodium salt of carboxylic acid. Now this process is used in the preparation of soap, that's therefore it is called as saponification. So here we'll take an example. CH3COO C2H5, the same compound, ethyl ethanoate. In the presence of catalyst NaOH, it will give you C2H5OH. So what happens from this NaOH? Here there is breaking of the bond. It will get split into Na and OH. And here in this compound, the bond is getting broken over here to give you C2H5 separately. So from here C2H5 gets bonded with OH of this and you get C2H5OH alcohol group, and the remaining part, that is CH3COO, gets bonded with Na. So you get sodium salt of carboxylic acid. So this is called as a salt. Okay, so whenever you see a compound that is having Na or K, potassium, it is referred as a salt of carboxylic acid. So this is a sodium salt of carboxylic acid, and this is ethanol. So ethyl ethanoate ester, in the presence of sodium hydroxide, you get ethanol and sodium salt of carboxylic acid. Now here the carboxylic acid was ethanoic acid. So this reaction is called as saponification. Reaction with a base. Same as other acids, ethanoic acid also reacts with the base to give salt and water. And we already know that when acid reacts with base to give salt and water, that reaction is called as neutralization reaction. Now the same thing goes over here. NaOH is a base, CH3COOH is acetic acid or ethanoic acid. It gives CH3COO Na. So from here, NaOH will displace or will remove hydrogen and form a bond over here to form CH3COO Na, and this removed hydrogen atom will combine with OH to form a water molecule. So this reaction is nothing but a neutralization reaction. Next one, reaction with carbonates and hydrogen carbonates. Whenever a carbonate is getting reacted, always remember there will be carbon dioxide compulsorily produced in a reaction. So the same thing goes over here. Ethanoic acid is taken, so it reacts with carbonate. Carbonate means sodium carbonate over here. It reacts with sodium carbonate to give CH3COO, and Na from here will displace hydrogen to form CH3COO Na, and the displaced hydrogen will form water molecule with the remaining compounds and carbon dioxide gas. Same thing happens when ethanoic acid or acetic acid reacts with sodium bicarbonate or sodium hydrogen carbonate. Okay, so it it produces basically similar compound, that is CH3COONA. Your H is getting displaced by Na, and the remaining molecules will form water molecule and carbon dioxide. So these are the examples of reaction with a base and reaction with carbonates and hydrogen carbonates. Soaps and detergents. You might have seen basic working of soap against dirt or oil stains on your clothes. Usually oil does not dissolve with only water, or dirt won't be removed with only water. As soon as this oil or dirt is washed or rinsed with soap or detergent, it is easy to remove it. So we will see how it actually happens. So before understanding the working of soap against the dirt, let's see what is a soap, what is the difference between a soap and a detergent. Now we have seen in previous slides what is saponification, and there we were getting sodium salt of carboxylic acid. So this is basically roughly the same idea over here. So soap is sodium and or sodium or potassium salt of carboxylic acids with long chain, but detergents are ammonium or sulfonate salts of carboxylic acids with long chain. So this is the first difference. Sodium is sodium or potassium salt, whereas detergents are ammonium or sulfonate salts. The second difference is soaps are effective with soft water only and ineffective with hard water. So basically there are two kinds of water. One is soft water, one is hard water. In soft water, soaps are very effective, means you will see the formation of foam. But in hard water, soaps don't work that much. The formation of foam you won't be able to see in hard water, but detergents are effective in both soft as well as hard water. This is the difference between soap and detergent. Now here in this diagram, it's already shown over here. This is a long hydrocarbon chain, and this is that carboxylic acid group with that sodium salt, that is COONA, and here is a ammonium salt, COO NH3. NH3 means ammonia, so it is ammonium salt. In a soap molecule, there are two parts. One is ionic part, that is hydrophilic. Hydrophilic means it will move towards the water molecule. Hydro means water, and a long hydrocarbon chain. Now this is a long hydrocarbon chain. So a long hydrocarbon chain, that is hydrophobic. Phobic means away. Phobia means scared, right? So hydrophobic means it will try to move away from water molecule. So the long hydrocarbon chain is hydrophobic part. This both part constitutes a soap molecule. So this is that this one dash means here there is carbon atom at each corners there are carbon atoms. So this is the general denotion of a soap molecule. This is a general structure of a soap molecule. This is the same part as this. So here is the ionic end, which is hydrophilic, and here is the long chain of carboxylic acid or hydrophobic part. So now we will look at the cleansing action of soaps, meaning how actually the dirt or oil is removed from the cloth. Most dirt is oily in nature. The hydrophobic end, that is hydrophobic means the long hydrocarbon chain, the hydrophobic end attaches itself with the dirt. So here you imagine that there is a cloth over here, and here there is oil or dirt particle. So when the soap or detergent is put into water, so there will be a mixture or a soap solution in which there will be many soap molecules. So what will happen is, in all the soap molecules, the hydrophobic part, that is the long hydrocarbon chain, that part will try to attach itself with the dirt. and the other part, that is hydrophilic part, it will try to be away from the dirt, or it will get surrounded with the molecules of water. So this, the total structure over here, that is formed hydrophobic part towards the dirt and hydrophilic part towards the water, molecules of water, this radial structure is called as micelle. Okay, so there will be many such structures forming in the solution, so we call it as micelles. So this is how it is shown: hydrophilic part, water loving, and water fearing, hydrophobic part. Now, an emulsion. Emulsion means dispersion of minute droplets, okay, of one liquid. So here I can imagine that droplets of oil which is not soluble in water. So you might have already seen, take oil in one container and just try to put water in it, it won't get mixed. But as and when you put soap solution, you will see that oil layer is getting splitted into tiny droplets of oil and water. So there is a slight mixture of these droplets, even though the droplets won't be easily soluble, but you will see such fine droplets of one liquid into the other liquid, that is water. That is called as an emulsion. So an emulsion is thus formed by soap molecule. The cloth the cloth needs to be mechanically agitated to remove the dirt particles from the cloth. Mechanically means just adding soap water or soap to the water won't remove the dirt automatically. So after adding the soap solution, you have to rinse it with your hand. So that mechanical agitation will remove the dirt particle from the cloth. So this is how the dirt particle or the oil particle is removed from the cloth. Scum. The magnesium and calcium salts present in hard water reacts with soap molecule. Now even in hard water there are certain salts, especially in hard water there will be magnesium and calcium salt. Now when it reacts with soap molecule, it will form insoluble product called scum. So there will be a layer forming after the mixture of soap molecule and water, which will be insoluble, means a layer of soap will be formed. Okay, so this will try to obstruct the cleansing action. Okay, so here we had seen how the cleansing action takes place. So with the soap molecule, that too in hard water, the scum that is produced, scum is that insoluble product that is forming, it will try to obstruct that cleansing action. So therefore we say that soaps, the working of soap is not much effective in the case of hard water, it only works in soft water, and hence there is the use of detergent now. So use of detergents overcome this problem, as the detergent molecule prevents the formation of insoluble product. So whatever scum was forming here, that won't be allowed by detergent molecules. So this detergent will try to avoid this problem. So it won't make any insoluble product, and thus it will be easy for the clothes to get cleaned. So this is the cleansing action in case of a soap and a detergent.